Welcome back. Previously we were discussing some of the miscellaneous case of correlation, and let us discuss about the next areas that comes under the correlation case. Next one, covariance between x and y. The covariance between two variables, specifically x and y, is defined as sigma within brackets x minus mean into again within brackets y minus y mean divided by n. It is another method of correlation that used to study the relationship between variables under study. Here usually we will be dealing with x and y variables, that is two variables, and the study of two variables is known as bivariate analysis. So with regard to covariance between two variables, it's another method for measuring the relationship between two variables. So the equation is sigma x minus mean into y minus y mean divided by n. I hope you know the meaning of sigma x as well as mean y and y mean divided by n. There will be x set of numbers and y set of numbers. I hope you know how to find the mean of x and y. The same equation can be simplified as sigma xy by n minus sigma x by n into sigma y by n, or the same can be again written as sigma dx dy by n minus sigma dx by n into sigma dy by n. I hope you all know what is meant by x, sigma x and sigma y and all. And regarding dx dy, this is an equation under study. If you take the deviations method in this scenario, then the equation will change back to sigma dx dy. See the equations, just add d before x and y. So sigma dx dy. I hope you remember the concept, because we have dealt the same set of cases previously regarding how to find dx dy, how to find dx, and how to find dy. We have dealt the same case regarding taking deviations on the basis of assumed mean as well as actual mean in the previous sessions. So just go through it. If you have any doubts, please let me know. So these are the major equations for finding the covariance between two variables of x and y. Usually you will be dealing with a question where the question itself directly mentioned that trying to find the covariance between such and such. So it's very simple. Just identify the equations, identify the details given in the question, and make sure which equation can be properly used to identify the answer. So when the covariance between two variables is divided by the product of standard deviation of those variables, we get coefficient of correlation. It is another equation for finding correlation. The thing is that here the correlation is measured on the basis of covariance between x and y. So in the question they may ask to find the correlation on the basis of covariance between x and y. Alternatively, it can be given as, in the question they specify as standard deviation of x and standard deviation of y. Whenever the standard deviation detail is given, it is sure that you need to find the correlation on the basis of this method. So correlation coefficient is covariance between x and y divided by standard deviation of x and standard deviation of y. I hope you know how to find standard deviation of x and y, because we have dealt similar cases and numerous techniques during the study of basic numerical skills. So we are not going into the detailed part of standard deviation or how to find standard deviation. Just remember, here there will be covariance for measuring x and y, and on the basis of covariance, the equation for finding the correlation is covariance between x and y divided by standard deviation of x into standard deviation of y. So let us deal with the case, then you will get a clear picture. Find the coefficient of correlation between x and y. Details of x is given, details of y is given. So naturally the next step is you need to create a table and substitute the details given in the table, details given in the question to the table. So here the x items are shown, y items are shown, and their totals are taken, because in the equations you need to write down the totals. because you have if you are familiar with the equation you will understand, because in almost all cases there will be sigma means total. So x and y is written directly to the table. We have taken the totals. Next, or as per the requirement of the equation, you need to find xy, because in the equation there will be xy. See, sigma xy is there, sigma x is there, sigma y is there, and also for finding out coefficient of correlation you need standard deviation of x and standard deviation of y. For finding standard deviation of x and y you need x square and y square. So that is the concept. So whenever you are asked to find correlation on the basis of covariance of variables, you need to substitute the details as per the given in the question to the table and find out x, y, xy, x square and y square, and you need to take the total. So let us substitute the details in the first case. Before we go into the coefficient of correlation, you need to find the covariance between two variables. So covariance between two variables, here you can use any of these equations, but depending upon the details given we can directly use these equations in this one, second one. See, sigma xy divided by n minus sigma x by n into sigma y by n. Sigma xy you already computed 270. Sigma x square is 203 and sigma y square is 371. Regarding sigma x square and sigma y square, you will be taking this x square and y square during the computation of standard deviation. So by substituting the remaining details 270, 203, 35 and 49, by substituting that you will get the value 3.57. So you have found the numerator of finding the coefficient of correlation. Here is the covariance between x and y, you got 3.57. Next you need to find standard deviation of x and standard deviation of y. So the equation for finding standard deviation of x is sigma x square divided by n minus sigma x by n the whole square. This is the easiest equation for standard deviation. You can either use this one or the deviation method, whatever the method, depending upon your discretion, but anyway do it wisely and correctly. So standard deviation of x is sigma x square by n minus sigma x by n the whole square. Sigma x square we already written 203 divided by 7 minus sigma x the whole square, 35 divided by 7 the whole square. By solving the basic mathematical step you will get 2. So one part is over. Next one, standard deviation of y. Standard deviation of y equal to sigma y square by n minus sigma y by n the whole square equal root of sigma y square 371 divided by n is 7 minus sigma y is given 49 divided by 7 raised to 2, and here also by using mathematical step you will get 2. So you have found the numerator value 3.57, denominator values 2 and 2. So just substitute directly in the equation. Coefficient of correlation equal covariance between x and y divided by standard deviation of x into standard deviation of y. 3.57 divided by 2 into 2 you will get 0.89. So this is how you have to find the coefficient of correlation using covariance between x and y. So just go through it, familiarize the equations. If you have any queries, please let me know. Let us go to the next case. New one, product momentum correlation coefficient. So before going into that part, previously we have discussed covariance between x and y. Here we have done a full-fledged problem where x and y is only given. Sometimes in the question they may give the details regarding total of x, total of y, total of xy, total of x square and total of y square. So don't get confused. The thing is that just substitute these details directly in the equation never think that in almost all the cases you will be given details and you need to substitute those details in the table and you need to work out the table. It doesn't always work like that. Depending upon the nature of the question, you might prepare a table, you might not. So understand the question wisely and be very cautious while dealing with cases or questions regarding this same area. I hope you have followed everything. Let us go to the next one. Product momentum correlation coefficient. There is not much explanation required regarding this area, and it is very rare that any question relating to this area comes for the exam, but we can't take any risk. Just understand the concept. Product momentum correlation coefficient is another method for measuring the correlation method. In the question they will directly specify to use this particular method, so whenever that question comes you need to use this equation. The equation is sigma x minus mean into y minus y mean divided by n into standard deviation of x into standard deviation of y. See, n into standard deviation of x into standard deviation of y. Just multiply standard deviation of x and y, then multiply that product value with n. That is the concept. Don't confuse that here it is n, here it is no n. Don't worry about it. We are multiplying the n with both the product of standard deviations. So this is the equation for finding product momentum correlation coefficient. So just work out a case, then you will get a clear picture. Calculate product momentum coefficient from the following data. Regarding series is given x and y. Number of observations 20 and 20 given. That means number of items. That will be 20 items. That is the concept. Sum of the squares of deviation from mean is 136 and 138. And sum of the product of deviations of x and y series from their respective mean is 122. Don't get confused with the sentence or typing. Just understand the concept. Here, let us pinpoint each details to a simple form. See, here number of observations is given. Number of observations means number of items. In x there will be 20 items. In y there will be 20 items. So total n means n small n, not capital N. N is 20. Next one, sum of the squares of deviation from mean. Whenever deviation is taken, it means d. Whenever deviation is taken from x, it is known as dx. Whenever there is sum or total of that squared value is taken, it is known as sigma dx square. See, sum of the squares, sigma of the deviation from mean, it means dx. Here for that means d, and when you are dealing with x, it is known as dx. When you are dealing with y, it is known as dy. So sigma dx square is 136 and sigma dy square is 138. And finally, sum of the product of deviations of x and y from their respective mean. Regarding deviations of x and y from their respective means, the simple meaning means it is known as dx and dy. And here it is given sum of the product of deviation. So product of deviation means deviation means sigma x and sigma y. Product of deviation means sigma x into sigma y. Sum of the product of deviations means sigma dx dy. So dx dy is 122. See, it's very easy. In the question you may find it confusing, but if you look closely you will understand the concept. Understand and familiarize each sentence and terms. Don't just mug up sigma dx square or sigma dy square. Understand the meaning of each individual variables. Then only you will extract the details correctly. So you have found all these details. Just substitute these details in the equation. Here standard deviation of x is sigma dx square by n minus sigma dx by n the whole square. You may think that in the previous question we have used another equation. That was one method. In this case we are using deviation situation. So the standard deviation for finding the x is sigma dx square by n minus sigma dx by n the whole square. Then deviation method is used. Remember, it doesn't mean that you need these two set of values. If you have only one set of value also you can find the answer. See, on the basis of details given you have dx square and n, but no information about dx and n, and there are no other additional information regarding how to find dx and dn. So we can assume that in this case standard deviation for finding x, the equation can be alterated like this. we can take only the first part alone, because there is no information regarding sigma dx by n the whole square. So we will go with the first part. So standard deviation of x is root of sigma dx square by n. If you substitute the details given in the question in this case, you will get 1 root of 136 by 20 equal to 2.61. So remember, in cases like this, you can neglect the variables or the details in the equation which is not given in the question. Don't get confused with that. Here there was no details regarding sigma dx by n the whole square. If there was additional information regarding that, you need to find that one. Since there are no other information, we are helpless. So we will go with the remaining one, sigma dx square by n. So standard deviation of x is 2.61. So similarly, you need to do the same for standard deviation of y. Equation here, this is a usual equation. Since there is no information regarding this part, we are only taking this one. See, we are taking only this one, sigma dy square by n. Just substitute the details in the equation and you will get the answer 2.63. So you have found the standard deviation of x, standard deviation of y. See, the equation is like this, and product momentum correlation coefficient equal to sigma x minus mean into y minus mean divided by n standard deviation of x into standard deviation of y. And regarding here, this one, you may confuse that there is no information regarding x minus mean, y minus mean. X minus mean means dx, y minus y mean means dy. So it can be written as sigma dx into dy. See, sigma dx into dy. You need to familiarize all these factors, then only you can go on with the simple problems. Otherwise you will get confused. So this denominator is simple sigma dx dy. That is the meaning of this entire set of values. So sigma dx dy is 122 divided by n is 20, already given. 20 into standard deviation of x is 2.65, standard deviation of y is 2.63. By solving that, you will get 0.89. So this is how you need to find the product moment correlation coefficient. So just go through it, familiarize each equations. You will be coming across these types of questions randomly in the case of examination. So don't get confused. So just go through it. If you have any queries, please let me know. We will continue with the remaining topics in the next session.